Most people think the danger on the Washington coast is the wave, the height of it, the wall of water, the thing you see in the footage. That is not what the people who model this for a living are actually afraid of. The reason emergency managers on that coast lose sleep is not the water at all. It is the clock. Specifically, it is a 10-minute window, and inside that window sit 3 to 6 minutes in which walking is physically impossible because the ground is still moving. Washington's Emergency Management Division, using funding from the National Oceanic and Atmospheric Administration, ran the numbers on that window. For a 10-minute delay from the start of the earthquake, the projection is nearly 18,500 casualties in Pacific County alone. That is more than half of every person standing inside the tsunami inundation zone when it starts. Not half the injured, half the people. And the reason this study exists at all is the part almost no one is telling you. Subscribe before we go further, because what follows is a story about a state that looked at the federal government's math and decided the federal government was wrong. Before we get into the details, I want to be upfront about something. On its own, a state agency publishing a hazard model is not news. Agencies publish hazard models constantly. Most of them land in a PDF that nobody outside a county emergency operations center ever opens. If I told you that a report projected heavy losses from a magnitude 9.0 earthquake on the Cascadia Subduction Zone, you would nod and move on, because everyone in the Pacific Northwest has heard some version of that sentence for 30 years. What makes this particular study worth a full breakdown is not the size of the number. It is where the number came from. Local emergency managers pushed for this work because they had lost confidence in the Federal Emergency Management Agency's projections for their own communities. Pacific County Emergency Management Agency Director Scott McDougall put it plainly to the Chinook Observer, saying that FEMA's modeling understated the risk considerably. That is a local official telling you the official federal picture of his county's risk was too small. The state redid the math. The math came back worse. Earthquake near me here is what the study documents. Washington's Emergency Management Division undertook the work in 2025 with NOAA funding, and it was released the following summer. Its purpose, as the agency itself stated, was to give cities, counties, and tribes an accurate understanding of the state's tsunami risk, so they could prepare, mitigate, respond, and recover. The scenario it uses is what McDougall described as a reasonable worst case, a magnitude 9.0 Cascadia earthquake at 2 in the morning on a midsummer weekend. Not a meteor, not a cinematic outlier, the realistic bad night. The study assumes full occupancy at hotels, RV parks, campgrounds, and marinas, which on the Long Beach Peninsula in July is not an assumption, it is a Saturday. Under that scenario, roughly 36,000 people are inside the Pacific County inundation zone at the moment the shaking starts. About 13,000 of them are full-time residents. About 23,000 are visitors. Nearly half the population in that zone is aged 65 or older. The study models walking speed at 2.45 miles per hour for people under 65, and 2 miles per hour for those over 65 and for people with mobility or vision impairments. It draws on 2020 United States Census data, an updated building inventory, and methodology and tools provided by FEMA and the United States Geological Survey. The earthquake itself, according to the study, produces 3 to 6 minutes of strong shaking felt across the entire state. The tsunami reaches Washington's outer coast within 10 to 20 minutes, and the inner coastal areas within hours. Casualty projections scale directly with how long people take to start moving. At a 10-minute departure delay, nearly 18,500. At 15 minutes, roughly 22,300. At 20 minutes, about 25,400. Those numbers are still being used right now to argue for evacuation funding that has not yet been appropriated, in communities where the towers that would save those lives have not yet been built. Earthquake near me +7. To understand why the clock matters more than the water, you need to understand what is happening 70 to 100 miles off that coastline at this moment. The Cascadia Subduction Zone is a fault roughly 700 miles long, running from Northern California up past Washington into British Columbia. At that fault, the Juan de Fuca plate is sliding underneath the North American plate. Think of 2 sheets of sandpaper pressed together and pushed slowly past each other. They do not slide smoothly. They catch. They stick. And while they are stuck, the pushing does not stop, so the rock behind the sticking point compresses like a spring being wound. The Oregon Department of Emergency Management describes that plate as currently subsiding beneath the North American plate and building pressure. That is present tense. It is happening while you watch this, in complete silence, with no instrument on the surface able to tell you how close the spring is to releasing. Clatsop County, Clatsop County. When it does release, the stored energy comes out in one motion. The seafloor snaps upward and lurches seaward. Everything above it, meaning several thousand cubic kilometers of ocean, gets displaced in seconds. That displacement is the tsunami. This is the first thing people get wrong about tsunami physics. A tsunami is not a big wind wave. A wind wave is surface texture, energy riding the top of the water like a ripple across a bathtub. A tsunami is the entire depth of the ocean moving, from the seafloor to the surface, as a single body. Out in deep water, it may be barely a meter high and pass under a fishing boat without the crew noticing anything, but it is carrying the energy of that entire water column. When it reaches the shallow shelf, the front of the wave slows down while the back keeps its speed, and the whole thing stacks up vertically. That is why the same wave that was invisible offshore becomes a wall inshore. Oregon's Emergency Management Agency projects tsunami heights of up to 100 feet along its coast for a Cascadia event. Clatsop County. The second thing people get wrong is the timing, and this is where the 10-minute window becomes the whole story. A distant tsunami, generated somewhere like Alaska or Japan, takes hours to cross the Pacific. Hours means warnings. Hours means sirens, phone alerts, organized evacuation, traffic control, buses. Cascadia gives none of that. The Washington study puts wave arrival on the outer coast at 10 to 20 minutes. Oregon's figures are similar, generally 15 to 30 minutes depending on location. No warning system on Earth is faster than that, because the warning is the earthquake. There is no agency that will tell you to go. The shaking is the instruction. USGES now stack the two facts. The shaking lasts 3 to 6 minutes, and Oregon's Emergency Management Agency estimates 5 to 7 minutes of shaking or rolling along its coastline. During that period, you cannot walk. Not because you are frightened, but because the ground is accelerating underneath you in a way that makes standing upright a physical problem. If the wave arrives at minute 10 and you cannot begin moving until minute 5, your entire evacuation is 5 minutes long. At 245 miles per hour, 5 minutes buys you about 215 meters. At 2 miles per hour, which is the speed the study assigns to nearly half of the people in that Pacific County zone, 5 minutes buys you about 175 meters. That is the distance from one end of a supermarket parking lot to the other. That is the entire margin. This is why the study models departure time as the primary variable, and why every additional 5 minutes of delay adds thousands to the projection. The wave height is a constant you cannot negotiate with. The clock is the only variable anyone has any control over, and right now, in most of those communities, it is not being won. Clatsop County. The historical depth here matters, because Cascadia is not theoretical. Oregon's Department of Emergency Management counts 43 earthquakes on that fault in the last 10,000 years. The most recent one occurred on January 26, 1700, and we know the date to the day because of one of the strangest pieces of detective work in the earth sciences. Japanese historical records document a destructive tsunami that struck their coast on that date with no preceding earthquake felt anywhere in Japan. An orphan tsunami, a wave with no local parent. It took researchers working across both countries to match those Japanese records to the geological evidence buried in Pacific Northwest tidal marshes. Or whole forests of cedar drowned in salt water when the coastline dropped several feet in an instant. Indigenous oral histories from the region carry accounts consistent with the same night. That fault has been silent for 326 years. The Seaside, Oregon municipal government cites an average recurrence of roughly 400 to 600 years for magnitude 9.0 or larger events, with intervals recorded as short as 200 years and as long as 1,000. We are inside the window, and we have been inside it for a while. Clatsop County +4. But here is the part that almost no one is covering, and it is the reason this study changes the picture rather than confirming it. The headline is a casualty number. The actual story is a disagreement about whose numbers a community should plan its survival around. Local emergency managers on the Washington coast had been unhappy with FEMA's modeling for a long time, and their objection was not philosophical, it was methodological. McDougall described the state doing an enormous amount of work analyzing the actual buildings in specific communities and determining how many people would realistically be present at any given time in order to produce a more realistic figure for who would be impacted and what the mortality would be. Read that carefully. The complaint is that federal modeling was counting the wrong population. Coastal Pacific County has about 13,000 residents inside the inundation zone. It also has about 23,000 visitors on a full summer weekend. If your model counts residents, you have understated your problem by roughly 2/3. And visitors are the worst possible population to have in a zone where survival depends on knowing which street goes uphill. They do not know the routes. They have not seen the maps. Many of them are asleep in an RV park at 2 in the morning, in a place they arrived at yesterday. Earthquake near me, earthquake near me. That is the cascade, and it is still unfolding right now, because federal loss estimates are not academic exercises. They flow into funding formulas, mitigation grant scoring, benefit cost analysis for infrastructure projects, and the arguments a county makes when it wants to build something expensive. A vertical evacuation structure, meaning a purpose-built tower or reinforced platform tall enough for people to climb when there is no high ground to reach, is the only workable answer for a place like the Long Beach Peninsula. That peninsula, as the study explicitly reflects, has a lack of reachable natural high ground, and as of the study's publication, no vertical evacuation towers had been constructed there, not one, and the case for building one is scored, in part, on models that local officials say understated the risk. If the projected loss is too low, the benefit side of the cost-benefit calculation is too low, and the tower does not get funded, and the population that would have used the tower is still standing in the zone next summer. That loop has been running for years. This study is an attempt to break it. Earthquake near me, scale it up, and the statewide picture gets harder. Washington's own loss estimate, produced with FEMA's Hazus software for a magnitude 9.0 Cascadia scenario, concluded that the tsunami alone could cause an estimated 50,000 to 65,000 or more casualties within the first hour. That represents 29 to 37% of the total at-risk population in Washington, and the agency notes that figure does not include daytime visitors. It also notes that funding limits meant the estimates only covered the mapped tsunami inundation zone, which means the earthquake damage across the rest of the state, the bridges, the highways, the fuel terminals, the water systems, is not in that number at all. Then there is the property side. In Pacific County, the study projects that 76 to 80% of buildings inside the inundation zone would be completely destroyed. Another 16 to 18% would take extensive or moderate damage. Between 99.4 and 99.9% of all buildings in the zone would sustain at least some damage. Replacement and repair costs land between $3.2 and $3.5 billion, and that figure excludes utilities, roads, ports, and other essential facilities. What that combination of numbers means is that the survivors do not get to shelter in place. There is no intact building to shelter in. The response problem starts the moment the water leaves and does not have a defined end. Washington State Geospatial Data earthquake near me, and the work is not finished. Pacific County has been awaiting new modeling for what is called an Alaska Max scenario, a distant source tsunami originating near Alaska that would take several hours to reach Washington. McDougall's concern about that scenario is one of the most counterintuitive things in this entire story. He has said he fears the fallout from a spontaneous, unmanaged evacuation of the peninsula during a distant source event could be worse than the waves themselves. Thousands of cars on a two-lane road in the dark, going the wrong direction, for a wave that arrives smaller than expected. Once both models are in hand, the county has planned a public education campaign built around teaching the difference between the two, because those two scenarios have historically been conflated in public messaging, and they require opposite responses. That campaign is being rolled out now. Earthquake near me +2. There is a precedent for the distant source case, and it is specific. The most significant distant source tsunami to reach that peninsula in recorded history came from the 1964 Good Friday earthquake near Anchorage, Alaska. It produced a 12-foot wave at Seaview on the Washington coast. That wave dissipated before it reached Pacific Avenue. It washed away the tents and cars of weekend campers who had been sleeping on the beach. Nobody died. Picture that morning, people standing on wet sand looking at the space where their vehicle had been parked the night before, in a town that never appeared in national coverage, because the story of a tsunami that kills nobody is not a story. That is the exact scenario that produces complacency. It is also the scenario that a Cascadia rupture does not resemble in any respect, and the people living on that beach today have inherited the memory of the wrong disaster. Earthquake near me. To keep this danger properly in proportion, here is the base rate. Scientists estimate a 10 to 30% chance that Washington experiences a Cascadia earthquake and tsunami over the next 50 years. Oregon's resilience plan puts the odds of a magnitude 9.0 specifically at 7 to 15% in 50 years, while Oregon's Emergency Management Agency cites roughly a 37% chance of a magnitude 7.1 or greater megathrust event in the same period. A USCIS study indicates the southern portion of the zone ruptures on average every 240 years and carries about a 40% chance of a magnitude 8.0 to 8.5 event in the next 50 years. Those are not next week numbers. A 10 to 30% chance across half a century is meaningfully different from a hurricane forecast, and anyone telling you this is imminent is telling you something the data does not support. Nobody can predict this. There is no precursor signal, no countdown, no bulletin. Earthquake near me +3. What the data does and does not tell us is worth stating precisely. It tells us the fault is loaded and has been for 326 years. It tells us that if it releases at magnitude 9.0 on a summer night, the modeled outcome in one Washington county is nearly 18,500 casualties at a 10-minute departure delay. It tells us that number moves to 22,300 at 15 minutes and 25,400 at 20. It does not tell us when. It does not tell us the rupture will be a full margin 9.0 rather than a partial segment failure, which is a real possibility with a very different outcome. And the honest comparison is the one that should stay with you. In 2011, Japan lost more than 18,500 lives to a tsunami, with over 2,500 people still listed as missing. Japan had seawalls, tsunami gates, breakwaters, evacuation buildings, and a population that drilled regularly. Those defenses were overtopped and destroyed. Washington's study projects a comparable casualty figure from a single county, without any of that infrastructure in place. Japan's loss came from the tail of a distribution their preparations did not cover. The distribution here is the same shape. The preparations are thinner. Washington State Military Department, which is why the useful response to all of this is not worry. It is a short list of things that are entirely within your control, starting today. First, if you live in or are visiting a coastal zone anywhere from Northern California to British Columbia, look up your inundation map before you need it. Washington's Emergency Management Division and the Department of Natural Resources publish inundation maps, pedestrian evacuation walk time maps, and current velocity maps, and Oregon's Department of Geology and Mineral Industries publishes Beat the Wave evacuation route maps for every coastal community. Pacific County's maps are posted through its Emergency Management Agency. Second, understand the single most important rule, which official guidance states directly. If you are in a tsunami inundation zone and you feel persistent shaking that makes you fall or struggle to stand, move to higher ground or inland immediately, and do not wait for guidance from authorities. There will not be time for anyone to tell you. Third, walk your route physically, at night, at your actual walking speed, not your imagined one, and time it. The study models 2.45 miles per hour for under 65 and 2 miles per hour for over 65, and for those with mobility impairments. If your route takes longer than 10 minutes at that pace, your route is a problem you need to solve now rather than then. Fourth, keep shoes and a flashlight within arm's reach of where you sleep, because the modeled scenario is 2 in the morning and the floor will be covered in broken glass. This is the unglamorous detail that determines whether you can run. Fifth, and this is the counterintuitive one, do not plan to drive. Roads will be cracked, bridges compromised, and a single stalled vehicle turns a 2-lane evacuation route into a wall. Every serious model in the region assumes pedestrian evacuation for a reason. Sixth, if you are on a peninsula or a spit with no reachable high ground, identify the nearest engineered vertical evacuation structure and know that the region has very few. North America's first tsunami evacuation structure was built at Ocosta School in Washington in 2016, and the first freestanding evacuation tower in the United States was completed at Tokeland in 2022 through the Shoalwater Bay Indian Tribe, with a structure planned at Westport. Seventh, if you rent to visitors or manage a hotel, campground, or RV park on that coast, put the evacuation map on the wall by the door. 23,000 of the 36,000 people in the Pacific County zone on a summer night are people who have never seen it. Eighth, show up when your county holds its public meetings on these models, because vertical evacuation projects are funded through political processes that respond to demonstrated public demand. Washington State Military Department +4. None of this is a story with an ending yet. The fault is loaded right now. The Alaska Max modeling for that peninsula is being finalized and released now. The public education campaign built on both scenarios is rolling out now, and the funding fights that determine whether any tower gets built on the Long Beach Peninsula are being argued now. 3 things worth watching over the coming weeks. Whether the Alaska Max results widen or narrow the gap between near source and distant source planning, whether FEMA's loss estimation methodology gets revised in response to states producing their own numbers, because Washington will not be the last state to do this, and whether any new vertical evacuation structure moves from planning to funded construction on that coast. I will be watching Washington's Emergency Management Division and the Pacific County Emergency Management Agency closely as those pieces land, and I will bring you an update the moment they do. Subscribe so you get it. If you live on that coast, or you are planning to visit it this summer, spend 10 minutes today finding out which direction you would run. That is the whole thing. That is the entire difference between the numbers in this study and a different set of numbers. Stay safe out there.